It's been just over a year since we open sourced TensorFlow, and we've been thrilled to see the adoption by the community and the pace of development both here at Google and all around the world.
TensorFlow is really the primary tool that we're using for a lot of our machine learning work in all of our products. Towards the end of last year, we actually rolled out a completely new translation system that was based on deep neural nets. In Gmail, we were actually able to roll out a TensorFlow model that, by understanding the context of the message you just received, we can predict likely replies. And this is a feature we call Smart Reply.
Diabetic retinopathy is the fastest growing cause of blindness. It's a complication of diabetes. We gathered a very large data set and had doctors grade the images. And then we, using TensorFlow, trained a neural net that does a pretty good job of predicting whether or not there is diabetic retinopathy in the image.
Can we use something like TensorFlow to make music, to make art, and to allow us to communicate better with each other? With TensorFlow, we're able to think abstractly, almost at a level of like improvisation with machine learning. We're able to try new things, to chunk models together in ways that were impossible before we had that kind of expressivity.
Dugongs are classed as vulnerable to extinction globally, so we do a lot of aerial surveys using drones. Then once you've done a survey of a really large area, you end up with tens, if not hundreds of thousands of photos. The goal was to find a way to automate that whole process, and that's where we've been using TensorFlow.
One of the things that we've been focusing on
have to necessarily know all of the underlying internals in order to get the distributed performance the best it can be. XLA is something that can compile down TensorFlow. Maybe you want to compile your graph ahead of time and get it down to something much more compact in terms of memory size, so that way you can easily load it and execute it on something that might not have as much storage space, like a mobile phone or some other portable, smaller device.
When we introduced the Hexagon Vector extensions, what we had in mind was enhancing user experiences with imaging features.
So the TensorFlow team said that you only needed low precision multiplies to be able to execute these neural networks efficiently. So we did some tests, and on the same graph, Inception v3, we were 8 times faster and 4 times lower power than running on the CPUs.
TensorFlow is great to work with, easy to work with, lots of capability. And so our engineering teams and their engineering teams working together, we were able to do something very exciting. This is just the beginning of what will end up being a long evolution of some great things we can do with machine learning in image processing.
In addition to sharing TensorFlow, Google has also shared an ecosystem of tools, which contains everything you need to go all the way from research to production. One such tool is TensorFlow Serving, and this is an open source, high-performance serving solution. Another great tool, which is actually quite beautiful, is the embedding visualizer. And you can use the embedding visualizer to interactively explore high-dimensional data sets. On the education side, General Assembly has done great work teaching TensorFlow.
For my final project, I was really interested in doing lyrics generation, and TensorFlow was a really great match for that because it allowed me to build out and utilize the models that I needed to be successful.
The TensorFlow community is thriving around the world, and we're excited about as many people as possible being part of it. TensorFlow is an open source project for everyone. We're looking forward to building this into something even better and more useful and more powerful in collaboration with the whole worldwide community.